Hello, this is Emad Mirabi. This is the first session of Electricity, Magnetism and Optics course. Topics covered in this session are electric charges, how do objects become charged, conservation of charge, electroscope, which is a device for determining if an object is charged or not, conductors and insulators, and static electricity. Okay, let's start. The building block of all matters is atom, and as we know, inside atom we have some particles. We have electron, proton, and neutron. Electron is negatively charged, proton is positively charged, and neutron is neutral. So every charged particle, the reason of charged particle is these charged particles are the reason for every charged material or charged object. We now know that all atoms are made of positive charges in the nucleus, surrounded by a cloud of tiny electrons. The charge of electron is 1.602 times 10 to the negative 19 coulomb. Coulomb is the unit of electric charge. Proton charge is positive E. So electron charge is negative E, proton charge is positive E, so they cancel out each other. In a neutral atom, we have the same amount of proton and electron, so they cancel out each other electrically. So a neutral atom is neutral. With respect to charge, a neutral atom has no net charge. Okay, atoms are normally neutral, meaning that they have exactly the same number of protons as they do electrons. The charges balance and the atom has no net charge. When electron removed from a neutral object, it will be positively charged. And when a particle gets excess electron, it will be negatively charged. The charges of all objects is an integer multiple of E. So based on this last sentence is also called the charge. We can say charge is a quantized quantity. Charge is a quantized quantity, which means we cannot have an object that has 1.5 electron or negative 1.5 electron. The charge of an object must be a multiple integer multiple of the charge of electron, and this is shown by a formula like this. Q is positive or negative Ne. Q is the charge of an object. Usually charge is denoted by Q. N is an integer and E is the charge of electrons. So charge of every object is an integer multiple of electron. So we cannot have an object with 2.5 electron gained or lost. Okay. Forces between charges. We observe that like charges repel each other. Okay, positive and positive charge repel each other. Negative and negative repel each other. Opposite charges attract each other, or we can say unlike charges attract each other. Based on Newton's third law, we know that these forces are action and reaction forces. For example, if this is charge 1 and this is charge 2, this is the force applied to charge 1 because of charge 2, and this is the force apply to charge 2 because of force 1. F1 and 2, F1, 2 and F2, 1 are reaction are action and reaction forces. They are of the same magnitude and opposite in direction. No matter, we don't care about if Q1 and Q2 are the same. Whatever Q1 and Q2 are, F12 and F21 has the same magnitude. The same case is here in the repulsion. So these forces have the same magnitude, no matter if these charges are the same or not. Okay. How do objects become charged? One method to charging particles or objects is through rubbing or friction. When rubbing a plastic rod with a cloth, this is a plastic rod. If we rub it with a cloth or duster, it gets negative charge. But how it gets negative charge and the duster gets positive charge? The reason is that electrons move from the duster onto the rod, because from the charged particles we read in the previous slides, only electrons move and transfer. Protons don't move. So electrons move from the duster to the rod, so that the rod gets excess electron and the cloth is electron deficient. So because cloth is electron deficient, it will be positively charged. Okay, the rod becomes negatively charged and the duster becomes positively charged. Okay, another experiment is rubbing a glass rod with a cloth. This time electrons move to the cloth, because glass rod tends to lose electron, but plastic rod tends to gain electron. This is intrinsic property of these materials. We'll later study this more. So electrons move from rod onto the duster in this case, and the rod becomes positively charged, and the duster becomes negatively charged. The duster becomes negatively charged. Okay. The number 2 way to charging particles or charging objects is through contact or conduction. What happens if you touch an uncharged piece of metal with a positively charged glass rod? Electrons from the metal will move onto the glass rod. The metal loses electron and becomes positively charged. Okay, so through contact, we can charge objects. Another example is like this. Let's assume that this is a metal sphere with a insulant base. For example, assume that it has positive 4 charges, or we can say it has lost 4 electrons, just like this. And we have an identical sphere. With no charge. Okay, if we bring them close to each other and touch, so that they touch each other, they will be something like this. Both of them will get, so if we bring them in contact with each other, both of them will get positive 2. This will be positive 2 and this will be positive 2. Of course, this positive 2 can be positive 2 coulomb or positive 2, or only 2 electron lost, or it can be 2 coulomb. Of course, coulomb is a very large quantity of electric charge. Whatever it is, by contacting, and the charge transfers, so we can make some object charged. Okay. The number 3 method is induction. Induction means without direct contact. Okay, charging by induction happens when charges in an uncharged metal object change without direct contact with a charged object. For example, we have two spheres here. These are metal spheres on insulin bases. So in the next step, we bring a negatively charged rod close to sphere A. Because this is negatively charged, a positive charge induced in here and a negative charge induced here, because they're totally neutral, so these positive and these negative charges must be equal each other. And then we can separate the spheres, and in the next step we can get this negatively charged rod far apart. So if we remove this rod, so now we have two spheres which are charged. One is positively charged and the other is negatively charged. The charge of them are equal to each other, but the opposite sign. We didn't use touch of this charged particle. Without touch, we applied this method. So because we applied it without direct touch, we call it induction. Okay, so induction is the third method so the three methods are rubbing or friction, to contact or conduction. The number 3 is induction, which is without touch. Okay, conservation of charge. When you charge something, no charges are created or destroyed. So we say charge is conserved. That means that the number of electrons and protons stay the same when an object is charged. Electrons simply move from one atom to another. Let's do one example. We have two identical spheres. One is charged positive 2 and the other is negative 6. If we touch them, what will be the charge of each sphere? Okay, let me draw what we have initially. Initially, this is positive 2. For the purpose of simplicity, I don't say the unit here. I can say it is positive 2 electron or positive 2 coulomb, but for the simplicity, I just say it is positive 2 and this is negative 6. And they are identical spheres. I mean, the size is the same, the material is the same. For example, both of them are made of steel. Okay, if we touch them with each other, because of conservation of charge, we'll have totally negative 4. And then the negative 4 will be distributed equally between these two spheres. So after touch, this will be negative 2 and this will be negative 2. Because we have totally negative 4, before and after we must have negative 4. Okay. And because they're identical based on the material of the metal or the size, the distribution will be even. So each one will be negative 2. We applied this based on conservation of charge.